There's one part of the quadratic function that we haven't worked with yet in our equations. In vertex form, we talked about the vertex. In standard form, we talked about the vertex and the y-intercept. We've talked about concave up and down. But two really important things we haven't talked about yet are the x-intercepts. So if we remember from the very first learning target, the x-intercepts are where the graph touches the x-axis. So in this example, this right here is an x-intercept, and this right here is an x-intercept. So 3, 0, and 5, 0 are our x-intercepts. These are really, really important parts of a quadratic function. In fact, they're so important, we actually call them solutions to the equation. That's how important they are. They're called solutions. So the solutions to a quadratic equation are the points at which the function intersects the x-axis, and they have three different names. The first name is obviously x-intercept. They're also called the solutions, which we just mentioned. And the last one, oh wait, I put this in the wrong place. And the last one is going to sound funny, but we actually also call these zeros of the function. They're called zeros, okay? Another word for them that we're going to see later is called roots. So there's actually 4 different names for these points on a graph. That's how important they are. They have a lot of different names, okay? Now, graphs can have 3 different types of solutions or x-intercepts. The first type is that it can have 2 solutions, and that's if a graph looks like this, or maybe it looks like this. And the reason this is called 2 is because it touches the graph at 2 points. 1, 2. This one at 2 points. Okay, so it has 2 solutions, it has 2 x-intercepts. In fact, we can say that it touches it twice. The other type is where it has just 1 solution, and that's a very unique looking graph, and that's where the graph touches it at 1 distinct point. So right here, it only touches the x-axis at 1 point, which happens to be the vertex. So it only touches once at the vertex. So that's when a parabola has 1 solution, 1, 0, 1 x-intercept. And the last option is if the graph never touches the x-axis. That can happen. Say I have a parabola way up here. That's never ever going to touch that line. Or maybe one way down here. It's never ever going to touch here. Okay? So it never touches the x-axis. This has no solutions, no x-intercepts. So those are the 3 different types that you're going to see. Okay, so x-intercepts come with a very interesting form of the function. So far we've talked about vertex form and standard form. This guy right here, that's in standard form. Okay, this guy is our new form. He's called factored form. He's got 2 sets of parentheses multiplied next to each other. Now I'm going to review from last unit. If I multiply these 2 things out, I'm just going to explain how these 2 equations are the exact same equation. They're exactly the same. This is standard form right over here. This is factored form over here. If you notice, and I go ahead and multiply these out like we learned in the last unit, you get negative 2x squared, sorry, negative 2x, 4x, negative 8. When I combine like terms, I get x squared plus 2x minus 8. Do you see how that's the same? They're identical. But one is written as 2 binomials and the other is written as a trinomial, because in these forms we can get different information. From standard form we learned that I can get the y-intercept. So this negative 8 is my y-intercept. So there's a point right here. I can also get my vertex from standard form, right? I can do negative b over 2a and get my vertex if I wanted to do this. So I would do negative 2 over 2 times 1. And get negative 1. So my vertex is going to be at negative 1. And then when I plug that back in, I get 1 minus 2 minus 8. So I get negative 1 minus 8 to give me a negative 9. So I have my vertex at negative 1, negative 9. So I can get those 2 points from standard form. From factored form, and that's what this is called, factored form, I get 2 points as well. And from factored form, in fact, I'm going to graph this and show you because I think that would be an easier way to see. So I'm going to go to my graph here. Actually, let's do this in Desmos. I think that'll be easier to see. Okay, so I'm going to go plug in my equation, x squared plus 2x minus 8. So x squared plus 2x minus 8. X squared plus 2x minus 8. Now, what I'm looking for is I'm looking for those x-intercepts. Okay, so see how I've got, if I zoom in here, I've got an x-intercept here at negative 4, 0. And the other one is at 2, 0. Negative 4 and 2. Go back to our equation. Here we have a 4 and a 2. So factored form tells us where those x-intercepts are. Factored form tells us that I've got an x-intercept here, and I've got an x-intercept here. So that means that my axis of symmetry is going through right here. So I've got a point right here on the flip side. And now I've graphed all my points. So x equals negative 4, x equals 2. These are called my solutions. And my x-intercepts are 2, 0 and negative 4, 0. Notice all I had to do to get that was I took these two numbers and I switched the sign. So factored form is really, really helpful. Really helpful. It gives us 2 additional points to help us graph. Okay. Now there's a reason this works instead of just switching the sign. We did just switch the sign for that example, but we're using something called the zero product property, which is a very simple property. It basically says if the product of 2 things equals 0, then one of those things has to be 0. So for example, if I want an answer of 0 and I'm multiplying and say one of the numbers is 7, the other number has to be 0, right? It has to be. Here's another one. If I want that to be 0 and one of the numbers is 3, the other number has to be 0. If you're trying to get an answer of 0, one of your original problems has to be 0 when you're multiplying. In algebra, it looks like this. If I have a times b equals 0, then I'm saying either a equals 0 or I'm saying that b equals 0. That's logic. Either the a or the b has to be 0 for me to get an answer of 0. So when I'm trying to find the zeros of the function, this is why they're called zeros. They're called zeros because if you go back to this graph here, notice that what's your y value? It's 0. So if y value is 0, we're basically saying, look, when are we trying to find an answer when y is 0? So I've got this guy here. He's being multiplied by that guy. So I'm saying, let me use a different color here actually. So I'm saying that either this x minus 10 is 0 or I am saying that this x minus 6 is equal to 0. So I've created 2 new little equations. When I solve them, when I try and get x alone, I add the 10 over. I get x equals 10. And when I do the other one, I add the 6 over and get x equals 6. The signs have switched. It went from minus 10 to positive 10, minus 6 to positive 6, but that is why it did that. So I've got an x-intercept at 10, 0, and I've got an x-intercept at 6, 0. Here's another problem, and the only thing different about this one is we have this guy in front. Now, whenever I have a factored form, I have to pull all the factors out and set it equal to 0. So I'm going to pull this guy out and write 7 equals 0. Now, does that make sense? That does not make sense, so we cross that out, and that is not a solution. Even though we had to pull it out to test it, that doesn't make any sense, that's not a solution. The others we are going to pull out. X minus 13 equals 0. X plus 12 equals 0. And then we're going to go ahead and solve these. Add the 13. I get a solution of 13. So I get an x-intercept of 13. And here when I subtract the 12, I get a solution of negative 12 and an x-intercept of 12. Okay? So what other algebra are we going to do with this information? Now that we know that this is factored form when you've got two binomials next to each other, there's some other stuff that I'm going to have you guys do with factored form besides just find the zeros. So for example 1, write each function in standard form. This unit is very, very much about reading directions and understanding what the question is asking. Remember, standard form is ax squared plus bx plus c. So basically, if I want you to write something in standard form, I want you to multiply this out. So we're going to do our box. Okay, and I'm going to put this x plus 1, x minus 4 on the sides. And do my box. So x times x is x squared. This is 1x, negative 4x. This is negative 4. Now, when I write this out, remember that 2 that's in the beginning there? That 2 has to stay there. And then in the parentheses, I'm going to do my combining like terms and writing it out. So I have x squared plus, minus, because negative 4 plus 1 is negative 3x, and then minus 4. Then I'm going to distribute that 2 to each of the terms inside. So I get 2x squared minus 6x minus 8. That is now standard form, ax squared plus bx plus c. This is standard form, and it was originally in factored form. Okay. If you want to pause and try B on your own, you can. It's always a good idea. I'm going to go ahead and do it out. Draw my box. On the outside goes the x and the minus 5 and the x and the minus 2. This becomes x squared. This becomes negative 5x. This becomes minus 2x. And this becomes 10. Okay, and then I have that 3 from the very beginning of the problem that I'm going to put here. And then in parentheses, I'm going to combine my like terms and write out my trinomial. X squared minus 7x plus 10. And then distribute that 3x squared minus 21x plus 30. That's standard form. I'm also going to have you write an equation if I give you information from factored form. So I'm giving you two x-intercepts. I'm saying, look, you've got an x-intercept of 2, 0 and an x-intercept of 5, 0. You've also got a equals 1 equals 2. So I want you to write two quadratic functions for each constant a. Now this means that you've got to know that factored form looks like this. This is factored form. So we just got to plug everything in. So my first equation says a is 1. So I'm going to put 1 here. My x and my x for my formula. And then my two roots are 2 and 5. So when I put them in, I'm going to make them minus 2, minus 5. So that's my first equation. My second equation, I'm going to use the second one. So now I'm going to use a to be negative 2. So I'm going to put that in front. And it's going to be x minus 2, x minus 5. I'm just taking my x-intercepts, plugging them into the equation, making them the opposite sign. Okay, so I'm kind of reversing it. I'm giving you the information and you're writing the equation. So that's the second thing I'm going to want you to be able to do. The third thing I'm going to want you to be able to do is graphing these functions and identifying x-intercepts and axis of symmetry. Okay? So if I say graph the function, identify the x-intercepts and axis of symmetry, we can go ahead and find those x-intercepts pretty easily. I can do x plus 5 equals 0, x plus 1 equals 0. Get the x alone. So I have an x-intercept at negative 5, 0. And I have another x-intercept at -1, 0. Now, I know a lot of you are maybe thinking, look, why is she writing all that out? Why does she just switch the sign? Because you're going to find examples later where switching the sign won't work. It'll be in your practice, I believe. The switching the sign won't work. You have to pull them out and you have to solve them. Okay, so now I've got points at -5, 0 and -1, 0. So there's that point there and there's that point there. Now remember, the axis of symmetry goes right between the x-intercepts. So I know that my axis of symmetry is going to go right here. Okay, now I need more information, right? I need to know where the vertex is. So that's what our calculators are for, or Desmos. We can go back into here. We can do, let's see, what is it? X plus 5, x plus 1. Yep. So x plus 5, parentheses x plus 1. And when I zoom out, oh, I didn't put a parenthesis here. There we go. That's why that's not working. There we go. Okay, let's zoom back in now. I can see that my vertex is going to be at -3, -4. That's my vertex. So I can go back and plot that at -3, -4. And I need 2 other points. So I'm going to go back to that, to Desmos, and I see that I've got a point at -2, -3, and -4, -3. You always need 5 points. So -2, -3. Oops, down one more. And -4, -3. There I've got my 5 points. And I've got my parabola. The last thing I want you to be able to do is not only be able to graph these, but then label all of this other information. If you want to go ahead and pause and try and do this on your own first, you 100% can. That's no problem. I'm going to go ahead and work it out. So my zeros, I'm going to get those first. Pull these out. I get x-intercept of 2, 0. And I get another x-intercept of 4, 0. So I'm going to plot those points. So 2, 0 and -4, 0. I'm going to write those here. 2, 0 and 4, -4, 0. The vertex, I'm going to go to Desmos, try and find my vertex. X minus 2, x plus 4. Let's clear that out. X minus 2, x plus 4. Is it x plus 4 or x minus 4? X plus 4. Okay, x minus 2, x plus 4. Okay, I'm going to find my vertex. It's all the way down there at -1, 9. -1, -9. And I've got a y-intercept at -8. So -1, -9. And then I've got 2 points on either side of that. So there's my graph. Okay. My vertex, -1, -8. Axis of symmetry is that invisible line going through the vertex. So that's at x equals -1. Remember, axis of symmetry formula is always an equation, x equals. Is that vertex a maximum or minimum? That is a minimum. Because this point right here, this is the point we're looking at. That point right there, that is the lowest point of the curve. So it's a minimum. It's concave up. And stretch, shrink, or no, that's looking at this number right in front. That's a 1. So that means that it's a no stretch, no shrink. Okay? If it were like a 2 or a 3, that'd be a stretch. If it were a fraction, it'd be a shrink. So this is all the stuff I want to be able to do with factored form. Okay? In your practice problems, there will be some, in fact, I'll do a little example here of this. Let me add a page here. Okay, so the only other thing that you will have to do is if you have an equation that looks like this. So this is an example where when I pull all of these things out to get my solutions, This one right here is a non-solution, so I cross it out. However, I can't just switch the sign of this 2x minus 7, because as I start to solve this and add the 7 over, I suddenly have to get rid of this 2, and when I do that, I get a fraction. That is okay. You can totally get fractions as solution. That's why I said try not to memorize it as just switching the sign, because sometimes you'll have two-step problems where your x-intercept will actually be a fraction. This one works where you can switch the sign. That just becomes x equals -4. But it doesn't always turn out that way. So just be careful in your practice. Watch out for problems like that. Okay? Good luck.